All right, so we are going to look at 3.3 today, which is solving quadratics. All right, so we are moving away from the factoring, which has its little chart up there, and we're going to look at solving today. Okay, we have two techniques, right? Up there we have 1, 2, 3, GCF, patterns, trinomials. We have three different techniques to think about when factoring. Today we're going to have two techniques to think about with solving. The first one is called isolating. Isolating, okay, when there is only a single x in the problem, okay? All right. When we are isolating, okay, use backwards, PEMDAS, which is typically the easiest order of operations to solve with, okay? So, example. We are solve for x. Those are the directions. Solve for x. Okay, here we go. 3x minus 8 equals 0. I know that's algebra 1. Just go with me. Okay, so when there is only a single x to solve for, okay, I'm going to highlight it. Notice how I only highlighted a single x. That means that this isolating technique is a good choice. Okay, now I'm going to write my PEMDAS over here. And I sort of am going to divide up my operations because add and subtract go together. Multiply and divide go together. Right? And I'm working backwards. So I'm going to start here at the add and subtract. And I'm going to add 8. Why do I add 8? Because that's what you're supposed to do first to get x by itself. Okay? You could divide by 3, but it's not very easy because you'd have to divide at 3x and 8 and 0 by 3. I don't want to divide 8 by 3. So I'm going to add 8. Okay, next, I'm going to divide by 3. As I'm starting with linear because you should feel very confident with that problem in the order that you did the operations in. Okay, now we're going to take this up and we're going to make it a quadratic. So we're going to do 4x squared minus 27 equals 0. Okay. Looks very similar to the first question. Well, the order is still the same. Okay, so I'm going to add 27, and then I'm going to divide by 4. All right. Okay, so I added an E. I added an exponent to this equation. So I need to undo the x squared. That's when you use the radical, okay? So I'm going to square root both sides. And you're like, okay, it's feeling good. Well, the square root of x squared is x, okay? But there's actually a little catch here, okay? The square root of x squared is actually absolute value of x. I'll explain, don't worry. Okay? Absolute value of x. Okay. We're going to finish the problem, and then I will come back and I will explain this statement. How does absolute value of x simplify? How do you solve absolute value? Split and solve. One is negative. One is positive. That's how absolute value works. One is negative and one is positive. Okay, now that I have x isolated, right? I isolated my x all the way down. Okay, I split it up when I did the root. Okay, can you simplify this radical at all? Well, I think 4 is a perfect square, right? I can't divide 27 and 4, but 4 is a perfect square. Okay? Is there anything else in the radical you can simplify? The answer is yes. So I'm going to let you look at it. Yes, Eve?
You do like the radical thing that we did on the 3.1. And so you take it and you do the closest radical that you can get to 27, which would be 9. And then you have leftover 3.
Yeah.
You have 3
yes.
on the outside and then square root.
Okay. Good. Yes. All right. How does 3.3 overlap with what we did in 3.1? Simplifying radicals, which happens to just appear in the problem. Okay, so really we have 3 root 3 on the top and a 2 on the bottom, and a positive 3 root 3 on the top and a 2 in the bottom. So x equals plus or minus, because notice they're exactly the same. And so I'm going to write my final answer like this. Whew. Okay, you can write them separately, or if they are the same, you can write them together with that plus or minus. There is a plus or minus button in Delta Math. Yes?
Are they all going to be the same?
No, it just happens to be in this one. So when you split and solve, you split and solve. If you happen to see some commonalities that can be written like this, you can put it back together. Okay, so I'm going to highlight this statement here. Yes, question? It's both. So it's plus or minus 3 root 3 over 2. So there are 2 answers. Right, I highlighted this because it's a rule, it's a definition. And the reason that we have this absolute value, it has to do with positives and negatives. X squared is positive. Makes sense because I'm squaring it. It's a positive result. if you square root a positive number, the result is positive. Positive result. How do you guarantee that you have a positive result? Absolute value is a positive result. That's why we use it. It's very specific rule to x squared and square root. Okay, so we're going to practice. We're going to use this rule, and we're going to practice with this simplifying on the radicals. So we've got the isolating technique. We work backwards, but then we have to pay attention to how our numbers simplify. Okay, so number 3. 3x squared plus 5 equals negative 7. Okay. So I'm going to write my PEMDAS over here. And the reason I'm using the PEMDAS is when I look to isolate, I only have a single x that I highlighted. Yes, question.
So are you required to write out the word PEMDAS?
No. I was going to say, this is just me telling you what I'm thinking about for the order. You do not have to write it. Okay? So I'm going to minus 5, and then I'm going to divide by 3. And then I make it to the exponent. Okay, minus 5. Divide by 3. Exponent. So I'm going to square root. Okay. And the square root of x squared is absolute value of x. And then okay, no. So that's where the order matters, is this 3x squared. The 3 is not part of the exponent, okay? So this and this are different, okay? Here, where the 3 is included in the grouping symbols, then this is actually 9x squared, which is not the same as this. Okay, so when I'm thinking of my order of operations, you have to divide that 3 before you square root. Otherwise, it doesn't really give you the correct result. All right. Anyone see simplifying that you can do? Wait for it. 1 second. I want to see more than one hand. Anybody know how to simplify that thing? 1, 2, Emma? 2 what? Wait, Maddie? 2i. Yes, 3.1. 2i. Okay. You can kind of simplify these radicals when it appears to you. Yes.
Sorry, I was gone. No, I think how does that work?
Okay, so remember that the square root of -1 is replaced by I. And so here, root -4 is root -1 times root 4, which is I times 2. Okay. All right. How do I solve absolute value? Split. 1 positive, 1 negative. Okay, so we get x equals -2i. X equals +2i. Notice how those two things are exactly the same. So my answer is x equals plus or minus 2i. If I notice some commonalities, I do write my answer together with the plus or minus. It is perfectly acceptable to write them separately, though.
Can you have like a negative 2i?
Yeah, it's a thing. Okay, good question. Positive 2i would be like here on the imaginary axes. Negative 2i would just be here. Yes. Even without that, yes, you can have a negative in front of the I. Yes.
What is it when you have like an I, but then you like have to do something like that?
Do some what?
Like, what is it where you have like a negative I or something, and that equals something else? No, I mean like, what does it look like with a number?
Like if you have like
Like I cubed is equal to negative I?
Yeah, I cubed.
I cubed. Notice that we are just doing I, which is the square root of negative 1. There's no extra powers here right now. Okay? So right now, we are only using the definition, this one right here. We're just using that definition part. Okay. Here we go. We're going to change it up a little bit. X minus 2 squared plus 1 equals 10. So I'm thinking of my PEMDAS. Can I isolate? Yes, because I can highlight a single X. I can highlight a single X. If you have one thing, you can isolate.
Can you go over your page a little bit?
Mm-hmm. There you go.
What does it look like when you can't isolate it?
B, the second set of our notes today. Right, we're doing A, which is about isolating. We're going to do B, which is not isolating. So I will show you. Yes?
But isn't x minus 2 squared x minus 2 times x minus 2? That would be 2x squared.
It is, except I can write it with 1.
Oh.
So I'm going to leave it with 1.
Okay.
Good question. We're going to talk more about that particular question on Friday. What happens if I could write it twice? Okay, here we go. I am going to subtract 1. And then I'm going to square root because there is no multiply or divide, so I just have 2 steps right now. Okay, x minus 2 squared equals 9. Notice that the square is the next thing you come to as you're working your way outside in. So I'm going to square root. And the square root of this thing squared is absolute value of x minus 2 equals, ding, ding, ding. What's the square root of 9? 3. Okay, looks a whole lot like absolute value equation. Split and solve. One side negative, one side positive. Okay, so what happens when you split and you start solving again? You're still just isolating. At this point, all of your solving has been about isolating, combining like terms and isolating, okay? Which is start back over on my PEMDAS. And so I'm going to add 2. X equals negative 1, x equals 5. That's it. That's your answer. Yes.
You may also write x equals negative 1 comma 5, right?
Sure. Yes. X equals negative 1 comma 5. Of course. All right.
What is the arrow +2?
Oh, that was me just starting to solve over again. So here, this got me to undo the radical, but then when I split it apart, I had to start solving again, and so I started back at the add or subtract. Okay, we have 2 more. 5. 2 parentheses, x plus 2 squared plus 3 equals 13. Okay, I'm going to let you start working. I'm going to come around and see. Okay, here we go. PEMDAS backwards because I can highlight a single x, so that's where I'm headed. I'm going to undo to get x by itself. All right, look, PEMDAS, so I'll write a little order of operations over here. PEMDAS, so we get minus 3 divided by 2 equals 10. X plus 2 squared equals 5. Okay, square root. Okay, square root equals, okay, this comes down to x plus 2 equals root 5. I'm looking at root 5. Root 5 doesn't simplify, so that's it. Okay, now I split and solve. So when you split your absolute value, one side negative, one side positive. Notice that when you split it, that's when the absolute value dissipates, goes away. Yes?
Why is the negative outside?
Because the negative, root 5 is approximately 2.1. So when I split this, it's negative 2.1 and positive 2.1. It's not inside the radical. It's not imaginary. Okay? It's just in front of the number. All right, so now I'm going to start solving again, and I'm going to subtract 2. Negative 2 minus root 5. Negative 2 plus root 5. Notice how they're very, very similar. Okay, let me combine it and then all right. I can write this together. Notice how it's minus 2 plus or minus root 5. And so you may, okay, combine your answer like this. No, you don't. Just when you're typing, sometimes it's easier to use that plus or minus button. You can always just copy and paste and change it. Okay, yes?
Would an alternate solution be x equals plus or minus root 5 minus 2? It doesn't really matter if you do.
Correct. Yeah, that's fine. As we move through more of our lessons, this is a more typical format that you will see in textbooks, but they are exactly the same.
Do you always put the coefficient or the number, whatever it's called?
I do. Mostly because it kind of looks like the quadratic formula. I can't sing the tune. Opposite B plus or minus the square root. Plus or minus the square root. Something, something, something. All over 2A. Okay. Question 6. All right, guys. This is as hard as it gets. 5. 2x minus 1 parentheses squared minus 2 equals 58. Okay, do your best. think about what we learned. Focus on how to simplify the numbers. I know where we may have made a mistake if you made one. So I'm going to PEMDAS. I'm not simplifying. I am solving. The direction said solve. Means I'm going to try to isolate the single x I've highlighted. So I'm going to add 2. I'm going to divide by 5. And then I'm going to square root. And then I'm going to reevaluate what I have in front of me. So add 2. Divide by 5. Square root. Okay. Absolute value equals root 12. All right, now I'm going to look at what I have. Can you simplify root 12? Yes. 4 and 3, so it's 2 root 3. So I'm going to write my 2 root 3. Okay, now I'm ready to split and solve. Okay, so 2x minus 1 equals negative. 2x minus 1 equals positive. Okay. Now, like terms, not like terms. Notice how this is the only thing with a radical. That means none of the rest of these things are like terms. So I start back over again. I add 1, and then I divide by 2. Okay? Pay attention to how the numbers simplify. It's not the isolating process you need help with. It's making sure you simplify your numbers correctly. Okay, so I'm going to add 1. Now, this is a preference of mine. I like my radical to be the second term. It's just a preference. Now I'm going to divide by 2.
Can you just do my minus 2?
No, you cannot because they are not like terms. Right? And okay, so 2 root 3 is the number. 2 root 3 is not the same as just a number with no radical. So they cannot be combined. Okay, so now I'm going to add 1. Same thing over here. Then I'm going to divide by 2. Okay. Now, what if I wanted to separate this? The 2 over 2, you're like, yeah, doesn't that simplify? Okay, well, it does, but be careful because you can't not do anything with this 1 in front. So it could be 1/2 plus or minus root 3. Now, I went ahead and I put them together because they're exactly the same except for the plus or minus. That's why I can do that. Okay? Notice that I did 1 divided by 2 and 2 divided by 2. I was able to divide the 2's because they're both outside the radical. 2 times root 3, then divided by 2. Multiply, divide, right? They match up, they undo each other. You could have also, very acceptable to leave it like this. You don't have to reduce that, right? Either one is okay for your answer format. So we have one description here. It's called zero product property. Now, most of you have heard of the solve by factoring, okay? But maybe you don't know why it works or why you do it. You're just like, I don't know, they just say to do this and I do it. Okay, you got to understand how it works so that you know when to use it. So the zero product property says if A times B times C equals 0. Those are factors, right? Think about the factoring we just did. So this is if A, B, C equals 0. Okay, so this is factors multiply to 0. So I'm saying it in words also. Okay, then A equals 0 or B equals 0 or C equals 0. This is called the zero product property. If you multiply to 0, then each of the factors are equal to 0. Okay? If factors multiply to 0, then each factor equals 0. Yes.
Wouldn't just one of the factors have to be the?
So that's why the word is or. Either x equals this, or x equals this, or x equals that. So all three of those potential
So
solutions.
would it mean that each factor equals, so there's the answer zero?
Hold on. I'm going to work it and check it and show you. Okay, so here we go. X cubed minus 7x squared plus 10x equals 0. Okay. If, then, if I have factors equal to 0, then each of the factors are 0. So that's the first thing I'm going to do. Okay? Is it equal to 0? Yes. Can I factor this? Yes. Right? Okay, so I am going to factor. Oh, now I jump on over to that little poster. How do I factor? Yes, let's do a GCF. Okay, and I'm going to do a little scratch work over here. I want to multiply to 10. Add to negative 7. Okay. So I've got my factors ready. I got x times x. And I got negative 2 and negative 5. Okay. Step 1. 0 and factor. Second thing I do, each factor to 0. Yes.
Why did you have to set it up in like the T-chart?
Because I didn't need to factor. If you want to do the T-chart to factor. We
Wait,
should.
That's all you need. Can you just write that out?
Yeah. If you know what the factors are, then just write the factors. You don't have to show the T-chart unless you need to.
So once you find the numbers with like that.
I found the numbers, but I know that it works. I'm not just putting them in there and not evaluating what I'm doing. Look at this. X squared minus 5x minus 2x plus 10. It actually works. I didn't just put the numbers down and not look at it. Okay? All right. Set each factor to 0. X equals 0. X minus 2 equals 0. X minus 5 equals 0. Okay, so let's see what we get.
Do you always have one that equals 0?
It depends upon what kind of factors you get. Okay, so here are my solutions. Okay, and I'm gonna do a little check here. Okay, just so that you can see. So we have x cubed minus 7x squared plus 10x equals 0. And this is what I'm going to do. I'm going to check the three answers. So if I have x equals 0, 0 cubed minus 0 squared plus 10 times 0, 0 minus 0 plus 0. Huh. Okay, I got 0. All right, so let's check x equals 2. Let's see if 2 works. 2 cubed minus 7 2 squared plus 10 times 2. So this is 8 minus 7 times 4 plus 20. 8 minus 28 plus 20 is 0. Like, it actually works. When you plug in these numbers, you actually get 0. Okay, you could also check 5. I don't really want to multiply by 5, but I will do it. Okay, so let's look. Okay, multiply x equals 5. Now, what if you look at this one? You could 1, 2, 3. Any of these lines, you could try checking it. So I'm going to do 5 times 5 minus 2 times 5 minus 5. 5 times 3. Oh, one of the factors is 0. That's what zero product property means. No matter where you plug it in, you're going to get 0. That's the whole point. But it's called zero product property, not 3 product property, not 7 product property, 0 product property. You have to set it to 0 first. Okay. X squared minus 6x. Oh, equals negative 6x. Alrighty. All right, I want to use the zero product property. So I'm going to set it to 0 first. And I'm going to try and factor. Right? Because it only works if you have factors. I have a chart on how to factor. Yes, Duncan? Yes, you would do a 3x. Okay, can somebody tell me what the 3x is called? Yes, Alex? Nope. What is the 3x called? The greatest common factor? Yes. Okay. Who can tell me, raise your hand, what goes in the parentheses? I just see one hand. Anybody? Yes, Claire?
3x plus 2.
Yes, 3x plus 2. Okay, I am giving you a lot of prompts and directions to walk you through the process. You need to practice prompting yourself so that you do the right steps, okay? Notice all of this over here, that's my words and my directions. You have to give yourself directions in your homework, okay? Second thing I do, now that I'm equal to 0 and I'm factored, then I actually use the zero product property. Each factor to 0. There you go. That's it. 2 answers. All right, last one. Okay. 8x squared minus 8x equals 6. Okay. Somebody else, what do I have to do first if I want to use the zero product property? Whoop, already answered. Oh, let's go in the back. Set equal 0. Okay, after I set to 0, what do I do? Come on, different hand. Come on. No, but I'm going to address that, yeah? You factor. Okay, so let's do it, and then that's a good point that I need to address. So I'm going to set it to 0, and so there was a suggestion about PEMDAS, which would mean isolating. The problem with isolating is, notice how I have x's highlighted in 2 spots. You cannot isolate if there's 2 x's. Okay, so part A, we only had 1 x. Part B, we've got multiple x's, so PEMDAS is not going to work. Okay, so I'm going to factor. I got a GCF of 2. Okay. And I'm going to just bring my factors over here, and I'm going to try to factor. Multiply to negative 12, so that's negative 6 and positive 2. I don't feel like thinking right now, so I'm just going to do the grouping. Just don't feel like it. 2x minus 3 plus 1, 2x. Okay, I'm feeling good about that. I just did the grouping method. Yeah. Right, so you can factor any way you want. That felt good to me, so I did grouping. Okay. Somebody else. Yes. Yes, set each to 0. Okay, so 2 equals 0. 2x plus 1 equals 0. 2x minus 3 equals 0. All right, guys, there's no x's there. Does 2 equal 0? No. There's no x. There's no answer from that particular factor. So we only get 2 solutions here.